9.3 Limiting reactant mass-to-mass problems. The problem is, given the equation 3 moles of sodium hydroxide react with 1 mole of phosphoric acid, 1 mole of sodium phosphate and 3 moles of water are produced. The problem, if I have 35.60 grams of sodium hydroxide, I like to write it here, 35.60 grams, reacting with 30.8 grams of phosphoric acid, how many grams of sodium phosphate are formed? And what is the limiting reactant? I'll do A and B together. So what this tells me is that I need to do 2 mass-to-mass problems from sodium hydroxide to sodium phosphate and from phosphoric acid to sodium phosphate and compare the two. The one of these reactants that gives me the least amount of product will be my limiting reactant, because one of these will get used up first, and when it gets used up, then no more product will be made. We have to find out which one of these reactants will make the least amount of sodium phosphate, and that will be the amount that's made, and it also will be the limiting reactant. So 2 mass-to-mass problems from sodium hydroxide to sodium phosphate and from phosphoric acid to sodium phosphate. So we'll do sodium hydroxide first. 35.60 grams of sodium hydroxide. We have to change it to moles first. So in 1 mole of sodium hydroxide, there are, I have it written over here, 40 grams. This number comes from the periodic table. Then I need to do the mole ratio step, and it is 1 mole of sodium phosphate to 3 moles of sodium hydroxide. This step takes me from one substance to another. Then now that I'm in moles of sodium phosphate, I need to go to grams of sodium phosphate. Grams of sodium phosphate in 1 mole of sodium phosphate. I need to get this number from the periodic table. I would add up the formula mass of 3 sodiums and a phosphate. And I've written phosphite there. Let me fix that. Now, this number I've already figured out is 163.94. And grams in 1 mole. I can go ahead and cancel all of my units, except for the unit that is asked for, which is grams of sodium phosphate. When I do the math, I will say 35.6 times 163.94 equals divided by 40 equals divided by 3 equals, and I got 48.64. What this tells me is that if all of my 35.6 grams of sodium hydroxide are used and gets put into the product, that will have 48.64 grams of sodium phosphate produced. Now we want to know how many grams will be produced if all of my phosphoric acid is used. So I'll do another mass-to-mass problem starting with phosphoric acid. 30.8 grams phosphoric acid. Same thing I did above there, change it to moles. In 1 mole of phosphoric acid, I have 98 grams. Do my mole ratio step. It's 1 mole of sodium phosphate to 1 mole of phosphoric acid. And these numbers come from the coefficients. And then 163.94 grams of sodium phosphate to 1 mole of sodium phosphate. When you do the math here, you get 30.8 times 163.94 equals divided by 98 equals divided by 1. 51.5 grams of sodium phosphate will be made. So 48.6 is less than 51.5. Therefore, this is the amount of sodium phosphate that is made, and sodium hydroxide is my limiting reactant. If sodium hydroxide is my limiting reactant, then phosphoric acid is my excess reactant. So we know what the excess and the limiting reactant are. So we have our answer to A and B. The limiting reactant is sodium hydroxide, and 48.64 grams of sodium phosphate are made. Now for C part, how many grams of the excess reactant remains when the reaction is complete? Well, phosphoric acid is my excess, so I want to find out how many grams of phosphoric acid will be used if I use all of my limiting reactant. 35.6 grams of sodium hydroxide. And I want to do a mass to mass, 2 grams of phosphoric acid. So I'm going from my limiting reactant to my excess reactant. And I will compare how much I used, which I'll find in the problem, to how much that I started with, given in the problem here. Subtract those. So change it to moles, and 1 mole of sodium hydroxide, there are 40 grams. That's the molar mass. Do a mole ratio between phosphoric acid, which is 1, these are the coefficients, and 3 moles of sodium hydroxide. And then I want to do the molar mass of phosphoric acid, which is 98 grams. 98 grams of phosphoric acid in 1 mole of phosphoric acid. So do the math. 35.6 times 98 equals, divided by 40 equals, divided by 3, and I get 29.07. 7. This is how much is used in the reaction. I need to subtract that from how much I had. Given in the problem, I had 30.8 grams of phosphoric acid. So for C part, I just say 30.8, which is what I had to begin with, given in the problem, subtracted from 29.07 grams, which is what I used, equals 1.73 grams of phosphoric acid left. And that is the answer to C part.